second lecture of the unit 3rd, that is recurrence, reduction and generating function. So in this lecture we will learn how we can find the numeric function from the given generating function. As in the previous lecture we have discussed how we can find the generating function given the numeric function, where AR are given, that we can find the AZ. Now in this lecture we will learn how we can find the AR where AZ is given. So AZ equal to 2 plus 3Z minus 6Z square upon 1 minus 2Z. This is a given AZ. So AZ equal to 2 plus 3Z minus 6Z square AZ equal to 2 plus 3Z minus 6Z square upon 1 minus 2Z. Ready? So now we know that by the partial fraction the power of the numerator should be always less than from the denominator. Where the denominator power is 1 here, so the numerator power should be 0 or less. Okay, so we should divide by the long division, minus 2Z plus 1, we can write in this way, minus 6Z square plus 3Z and then plus 2. Now we want to find here 6, so we should multiply by the 3Z. Some students will think about that we should multiply by the minus 6. No, because after the multiplication we have to subtract, we should change the sign. If you will take minus sign here, so minus minus it will already become plus and it should be plus, and you will change the sign, it become minus, so it will difficult for you. So 3 2 just 6 with the minus 6Z square and minus 3 2 just 3Z something plus 3Z. Just change the sign, becomes 0, it becomes 0, only 2 is here. So we know that if we want to write here quotient plus remainder upon divisor, there is a formula. Okay, so we should write in this way, 3Z plus quotient remainder 2 upon 1 minus 2Z. Okay, now we should write in this way, 3Z plus 2 1 minus 2Z to the power minus 1. Now we should expand this. We know that the expansion of this series 1 minus Z to the power minus 1 is a geometric progression. 1 minus Z equal to, this is a expansion of this series, 1 plus Z plus Z square plus Z cube plus Z to the power R dot 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 to infinity. The similar thing is here, but the term is a 2Z, so you can express in this way, 2Z to the power 1 plus 2Z to the power 2 plus 2z to the power 3 plus 2z to the power r. Now I am going to open the new paint. Now you should write, just multiply by 2 here. Then you will get 2z, 3z plus 2 into, just you should multiply 2 plus 2 into 2z plus 2 square z square and 2 की power 2 into 2 cube z cube plus dot 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 2 into 2 की power r z की power r. Just you should add the similar term, 2 to the 4 and 3, that is 7z. It becomes 2 plus 7z plus, rest terms are the power term, they are differ from the other terms. 2 into 2 square z square, 2 into 2 cube z cube, 2 into 2 की power r z to the power r. So just we know that the coefficient of z to the power r is known as numeric function. So it is the, we can write in this way, ar. Here the z to the power 0 means that r equal to 0, where r equal to 0 the result is 2, where r is equal to 1, z to the power 1 there is 7, and when r greater or equal to, it becomes 2 into 2 to the power r. We can write 2 to the power r plus 1, final answer. So we can write in this way. Okay, in the first lecture we have explained what is the numeric function, so we can write in this way. Okay, so this is the answer, 2 7 2 to the power r plus 1 something. Getting? Now this is a numeric function, and we can find the generating function. If we have the numeric function ar, how we can find the generating function? Just we can find the generating function like this. If we have the numeric function ar equal to 1, ar equal to 1, so this is a constant function. ar equal to 1 is a constant function. So if we will put r equal to 0 and even r equal to 1, even r equal to 2, even r equal to 3, then the result will be 1. Even ar equal to 1, because this is a constant term. If you will change 0 1 2 and 3 ar, so all the times the result will be 1. So just you should put az equal to a0 z0 plus a1 z1 plus a2 z2 plus ar zr. Okay, so just put the values 1 z0, 1 z1, 1 Z2 1 ZR. One plus Z plus Z square plus Z to the power R. So this is a series. We know that this sum of this series is 1 upon 1 minus Z. This is a geometric progression of infinite. So the final answer is 1 upon 1 minus Z. So you can see here, if the numeric function is AR equal to 1, the final answer is 1 upon 1 minus Z. Similarly, if you will have AR equal to alpha to the power R, just put alpha 1, alpha 2, alpha 3, so it becomes 1 upon 1 minus alpha Z. If you will have, now we are going to solve this problem. AZ equal to 2 upon 4 minus Z square. So it will take some time. Now we are going to solve AZ equal to 2 upon 1 minus 4Z square. Two upon 1 minus 2Z का square. So we can write two upon 1 plus 2Z. Just you should apply the formula a square minus b square 1 minus 2Z. Just you should add and subtract. Apply the partial fraction. 2 upon 1 plus 2Z 1 minus 2Z. So a upon plus b upon 1 minus 2Z 1 plus 2Z. Just solve. One plus 2Z b 1 minus 2Z and upon, after taking the LCM we have the same thing, 1 plus 2Z. This will cancel. So it becomes 2 equal to a plus a into 1 plus 2Z and plus b 1 minus 2Z. Just you should multiply like this, a 2 a into Z plus b minus 2b into Z. Just compare for the coefficient of Z. So it should be here only 2, not the Z here. So the coefficient of Z 2a plus 2a minus 2b equal to 0. Just compare the coefficient of Z equal to 0 because Z is not here. So you should write like this, plus 0 into Z to the power 0 into Z. Okay, so you will multiply the 0, it becomes 0. So 0 you can add anywhere. So the coefficient of Z is 0 and the coefficient of Z is here 2a minus 2b. So the 2 should be cancelled. So it a equal to b. From the first equation we got a equal to b. Now we are going to compare coefficient a plus b equal to 2, a plus b equal to 2, constant term comparison. A equal to b, we have already proved. So a plus a, if we will put b equal to a, then it becomes 2a, and 2a equal to 2. The value of a is 1, value of a is 1, but we know that a equal to b, so the value of a is equal to 1 and b is equal to 1. So this equation becomes 1 upon 1 minus 2z, b upon 1 plus 2z. Here we can see 1 upon 1 minus 2z, 1 upon 1 plus 2z. Now you should take as a denominator, put in the numerator, and just expand these two series, and you will get 2 to the power r plus minus 2 to the power r, like this. If we will solve further to this term, then we will get one upon 1 minus 2z plus 1 upon 1 plus 2z. So it becomes 1 minus 2z to the power minus 1 plus 1 plus 2z to the power minus 1. So it becomes 1 plus 2z plus 2z to the power minus 1 or plus 1, 2z to the power 2 plus 2z to the power r. And the similar, we can expand this 1 minus 2z plus 2z to the power r, and the minus 2, and the minus 2z to the power 3. So and plus minus 1 to the power r, z to 2z to the power r. So the coefficient of z to the power r is known as the numeric function. The coefficient of z to the power is 2 to the power r. Here is a minus 2 to the power r. So we can say 2 to the power r plus minus 2 to the power r is the answer. Here is the answer. Okay. So we can say like this. Now we can also solve this problem, z to the power 4 1 minus 2z. Just you should divide by this term, and you will get this solution. So, and if you will put, we have the another example, and if we have we will put 0 from r equal to 0 to r equal to 8 0. So the from the ninth term this series will be start. So z to the power 9 2, okay, and 10 3 z to the power 10, 11 z to the power next 4, and 12 z to the power something, 13 z to the power 14 z to the power, just like that, and taking z to the power 9 as a common, so it becomes 2 plus 3z plus 3z square plus 2. These terms should be here, 2 3 3 2 3 2, next term should be 0, and 1 3 2 2 3 2 2. Okay, just we should we put the value, then we got the solution. Now we have the two series AR and BR. So the numeric function, after putting the value, we got the numeric function like this, and we got the numeric function like this, AZ BZ. Just we should multiply these two terms like this, and after the partial fraction we got this in this situation, and just you should expand these two series and you will get the answer. Just we have solved this series just 2 minutes before in the previous slides. Okay, just you should solve with the help of partial fraction. These are the references. Thank you.